Good morning, everyone. Uh, Jalpaben Bhatt welcome you all to the third day of IEEE sponsored FDP on recent tools for integration of smart systems. For today's morning session, we have our speaker with us, Mr. Iqbal Mujjawar. Sir is an assistant professor, mechanical engineering department in Thakur College of Engineering and Technology. He has completed his ME in thermal engineering and BE in mechanical engineering. He has more than 7 years of teaching experience and also has many national and international publications to his credit. Without any further delay, I hand over the session to you, sir, for a session on Introduction to PLC and its application. Welcome you, sir.
Okay, good morning to all. Today I'm here to present an introduction of PLC. The full form of PLC is Programmable Logic Controller. And I hope this is not new. And most of the participants, they're already aware what is PLC. Because it is there from late 1960s, 70s. It is there in the industry we are using. But still, some advancements are there in PLC. And whenever we are talking about the automation, Industry 4.0, automation, IoT in industry, then ultimately we require a brain. Brain is nothing but some kind of controller and processor. And for that purpose, normally, as sir as yesterday, sir, one of my colleague explained IoT kit, some explain regarding the Industry 4.0, some explain about the VR, AR, and all those things. For all those things, we require a controller. Okay, various controllers are there in market which we can use. But as far as industry is concerned, mechanical industry or any process industry is concerned, for that purpose, one special made controller is there, that is called PLC, which we can use, and that we are going to learn in detail through this session. This is 1.5 session. Before starting this, my PLC slides and theory session, I would like to share one small, I can say, the video in which, in brief, hardly in 4 minutes, they explain in brief what is a PLC, by which everyone will get some idea regarding the PLC. Then we'll go with some theory part, okay? And after that, again, I will start the coding. So we are going to cover a small project at the end, okay? For one bottle filling mechanism at the end. Just I will share once more time my screen. To stop my slide.
Okay. Today, we are going to talk about the basics of a PLC.
Yes, sir. It is audible.
Audible?
Yes, sir.
Okay. The workhorse of industrial automation. The Programmable Logic Controller, or PLC, is a special purpose computer. It has no display, no keyboard, no printer, no hard drive, and hides in the control panel out on the factory floor. But it is still a computer. Initially, the PLC was a replacement for panels of relays, devices that turn on and off. Making a machine run using relays as logic was time-consuming and challenging. And making a change in the logic or the operation of the machine was almost as complicated as starting over. Relays also fail far more frequently than computer components, so that relay logic required more downtime to keep it running than newer PLC-based controls. On top of all of that, relays use a lot of electricity, make lots of heat and soot, and take up lots of space. An installed PLC is deceptively simple in appearance. You have a CPU module and input-output devices referred to as I/O. Sometimes the I/O is part of the CPU, and sometimes it is in other modules. The CPU communicates with the I/O, so in most systems, they share a backplane that physically holds them in place and electronically connects them. In other equipment, the I/O modules can be miles away from the CPU and connected with data cables, so that the PLC is not limited to a single cabinet or even the same building. Since the PLC is a computer, there's no need to limit it to only digital inputs and outputs. Over the years, the manufacturers added analog and other numerical inputs and outputs. To make these numerical devices useful, they included calculation capability in the programming as well, so that we can now calculate, for instance, statistical process control, or SPC values, and put PID controllers directly into the PLC program. Since this is called a programmable logic controller, we need to program it. Most PLCs are programmed using an application running on a standard desktop or laptop PLC. They communicate with the PLC using Ethernet or proprietary communication bus, depending on the manufacturer. Most manufacturers seem to have settled on Ethernet and/or USB in recent years. Unfortunately, the PLC manufacturers have failed to agree on how we program the control logic. Although most of the manufacturers claim some form of ladder logic, the specifics of that language are different for each manufacturer, including different capabilities, different ways of doing the same thing, and even differences in the order in which the CPU processes the various pieces of logic.
Okay. After that, some theory part is there regarding how they overcome to agree on a single language. As it is mentioned that every manufacturer having their different own style to make the ladder coding. That is a later part. But ultimately here, from this video, we will get the idea regarding what is a PLC and how it is a better than RLC relay-based logic controller, I can say, which is previously in industry they are using. Then regarding the PLC, as we can see here, based on the NEMA standard, that is the Nation Electronic Manufacturing Association, based on the Northern American. We mentioned that what is a PLC? PLC is nothing but a digital operating electronic apparatus. Is a one apparatus like a controller, which is there in market, which used to programming memory for internal storage of instruction, to implement the specific functions such as the logic, sequencing, timing, counting, arithmetic, which is required for the control the processes. Might be in digital or analog models, various type of machine and processes. Then similar kind of things we can use with the help of our regular controller also, like other controllers might be 8051, any other control which might be electronic people, they know better than me. But what will happen to withstand that mechanical environment, that high temperature, I can say, the vibration, all those things. Because of that, the special kind of controller is designed for mechanical industry, that is a PLC. Ultimately, this is also controller, and other controllers are also there in market. They can do the similar kind of task, whatever I explained right now in that definition. But to stand that environment and all those things, here we need to use the PLC, programmable logic controller. Now, as I said, it is replaced the relay-based circuit in late 1960. And as in the video, you already aware what is the drawback of a relay-based circuit. It required huge space, lots of heat dissipation is there. It's difficult to troubleshooting, replace, wiring, understand. If suppose I want to change the coding, lots of issues are there. Because of that, especially the PLC is designed to overcome that problem. And it became popular in 1980s as the cost is dropped. We are getting a lesser cost, and nowadays in any industry, wherever you saw the automation in any process industry or mechanical industry, if any kind of automation is there, then definitely you will get the PLC over there. Now, if you can see the little bit history more, it is developed by GM, General Motor, okay, by Hydramatic Division. The first program they developed in 1968. As I said, to limit the high cost inflexible relay control system, that is the aim to develop the PLC that time by General Motors. The design in such a manner that is in modular form, so that we can do the sub-assembly, could be remove easily, replace, repair, anything we can do, which is quite difficult in relay-based circuit that time. That time we can unable to, because that huge wirings are there. The relay size is also huge in late 60s or 70s, I can say. Nowadays, very small size relays we are getting. But that time the relay size is very hard. We can say the wall size, entire wall size, the ladder relay coding is there that time. Entire wall, I can say, 2-3 wall size, and that in the that much huge component, huge wiring to identify to troubleshooting is quite difficult. Which is replaced by small box, no doubt box also. That time it's a The size is very big PLC, but still it is within that small area we can easily do the troubleshooting, and it's a very logical form. We can see in further slides what exactly is there, why it is easy as compared to relay based circuit. The control system needed to capable to pass the data collection to the central system. The system had us to be reusable. That same PLC we can use in another system also. Just I need to change the coding. That's it. The ultimately PLC is same. Okay. Just I need to connect the input and output components to the PLC at particular port. Need to change the code, and again the same PLC I can use some another application also. That is also possible, which is not that much easy in the relay based circuit. The method used to program the control had to be simple so that could be easy understand by the plant personnel. That is a one again benefit with the help of using the PLC. Now I'm explaining the relay based circuit. I'm assuming that here most of the faculty participant, they are not that much good in electronics part. Because of that I'm going with a very basic part, okay, by which at the end all are in same level. Then here I will explain what is a relay based circuit first, okay, then we'll compare it both at that, and then you come to know that why relay based circuit is PLC is better than the relay based circuit. Then what is a relay? As you can say, relay is nothing but a electromagnetic switch. It is one kind of switch only. Okay. Here normally whatever the switch we are using at our offices, home, that is a normal state switch we can say. If I press it, the system will be on, might be fan, light, anything. If I again press it in opposite port, then it will off it, on off kind of switch. But that we need to provide mechanically, sorry, physically I need to press it. The same thing is, suppose I want to control with the help of some kind of signal, 5-volt signal. Then in that case, I need to use some devices, the electronic devices. Then here, the relay circuit, relay switch is very beneficial for us, by which we can with small supply. Let's say I'm supplying the 5-volt supply over here, 5-volt or 10-volt supply over here, and I can control the 230-volt circuit, the control to control the fan and all those things, anything AC supply. Then relay based circuit, relay switch is very important. Then how relay switches work? Here one iron cone is there, which is bound by the coil, and here we are having the iron one connected to the switch. This is the main supply that I want to control with this secondary signal. Yeah, the signal received by the controller, I can say. Then here, let's say I supply the current, small current, okay, across this iron core through this coil. Then magnetic flux will be generated, and because of this magnetic flux, the ion coil will be attracted over here and it will be connected. And because of this connection, the required current will be start flowing across this coil. Once I supply the current to this coil, this current might be generated by manually also, might be generated by system logic also, based on whatever the logic I feed it. Based on that also possible, the controller, whatever the control is generated. But ultimately with this current, I'm controlling the flow of current across this node. Here I can connect anywhere, as I said. Okay, this is a relay based circuit. Okay, like this relay based circuit is work. Now how does PLC replace the relay in the electrical system? Then we can see this 4 diagram. This first we'll see the diagram A. In the diagram A we can see there are the 2 rungs. Okay, in a rung 1 this is across 24-volt supply. Okay, here first rung I can say the switch S1 is there, which is connected to coil K1. Okay, when coil K1 is energized while pressing the S1, this internal switch, again I can say the internal switch, this here also I can give the name K1. Okay, when S1 is pressed, K1 coil will be energized, then this K1 switch will be closed, internal switch will be closed, and the lamp L1, yeah, any device whatever connected to this L1 will be start working. This is a circuit diagram. Here I just explain how relay work, and this is a basic circuit diagram how we can design the relay based circuit RLC for simple to control the L1 with the help of switch S1. Okay. Now when the as I explained, when the user press S1, the relay K1 pulls its internal switch and lamp L1 will be turned on. Okay, this is basic RLC circuit, relay logic circuit. Now the same thing is, suppose I want to replace with the help of PLC, then it doesn't require all those things. What I need to do here, across the PLC, I need to connect the input switch with the input terminal, the output component with the output terminal, and we need to connect the power supply as per the requirement. Okay, then whatever the logic here, everything is physically connected. In RLC relay based circuit, everything is physically connected. The K1 is connected with internal switch S1, S1 is connected with the K1, and this internal switch is connected with L1. Is everything physical wiring is there? Everything is physical wiring, but here logical wiring is there. No physical wiring is there because everything is connected with the PLC, not with each other. Then I can use as per my requirement. I can change it in future. That is the advantage of PLC. Then here what will happen? Whatever this logic is, a similar kind of logic is there inside also, but not physically. This is a computer generated logic, computer generated connection. I can say I can change it in future also by changing the code, and ultimately I can execute the ladder coding. Then what is the advantage here? I might be some of the participant can say that, sir, ultimately the same thing now. The same thing we have created here also and here also. The similar kind of logic is there. But what I said here right now, this is a physical wiring and this is a logical wiring. What is the difference? Just I will share the screen. Sorry, the whiteboard, and here I can explain the same thing. Let's say this is a PLC. Okay, same thing I will draw here, and here let's say the switch S1, which is connected with the input terminal, and here the lamp is connected. Yeah, any terminal is connected. Might be lamp, motor, whatever the output device I connected. I want to control S1 with this L1. When I press S1, L1 should be on. I uploaded, and similar kind of, if suppose relay logic, if I created, the relay logic will be same as it is shown over there. Here will be K1, K1, and here the internal switch K1 will be there, which is connected to this lamp. Okay, this is S1. When I will press S1, this K1 is connected with each other, then K1 will be closed and L1 will be closed. This is physical wiring. This is RLC circuit, relay logic circuit, relay logic control, and this is PLC. But let's say in future, in our plant, whatever the process where I'm using this kind of circuit, some changes are there, and we decided that instead of controlling this L1 with S1, okay, I want to control some another switch, not S1. I need to control some another switch S2, and now S1 will be control L2 device, some L2 devices there. Okay. Then in the relay based circuit, what will happen? I need to change the entire diagram. Okay, because not diagram, I need to change entire circuit actually, physically circuit, because this is physical wiring. Then again I need to design new circuit like S1, which is connected to this K1, K1, okay, and here I will use S2, which is connected to K2, okay, because two switches are there. Now one more picture can come in the picture. Then again internal switch 1, which is connect L1. Okay, I'm drawing with the help of mouse. Because of that, my diagram is not that much good. Just excuse me for that. Just try to understand what I'm explaining, the logic. Okay. Then this is a very simple, previously the circuit, because only S1 is connected with L1. But now two switches are there, S1 and S2, which is we need to control with L1 and L2. Then I need additional switches. I need additional lamp, no doubt, which is required because the additional component is added. I need to control one more device, but wiring is also added. I need to arrange that all those things. I need to, again, lots of changes are there. But if the same thing, if I want doing the PLC, it is very easy. It is shown in the slide. It is an input element. Here input is written. And if I'm not wrong, here output was written in the diagram. We'll see afterward. Because these are the terminal, input module and output module. Then what I will do, I will just connect S2 switch over here. I will connect one lamp over here. And my circuit diagram is completed now in PLC, which is quite difficult in RLC, relay-based circuit. But in PLC, it's very simple because I just need to connect. But to get the required execution over here, I need to just change the logic, just change the code. Wiring is very easy. Connections are very easy, but which is quite difficult in relay-based circuit. That is the advantage. And because of that, in industry nowadays, instead of relay-based circuit, we are using the PLC circuit. I hope all of you understand what I'm trying to explain over here. If any doubt, you can raise the hand or you can share in chat section. Anyone? Any doubt till here? Anyone? Okay. I received no, sir. Okay. Any doubt is there? You can share in chat section. Meanwhile, okay, raise the hand by which we can rectify that particular problem. This is all about the PLC and RLC relay-based circuit and programmable logic controller and why PLC is used. Because here, ultimately, only we need to change the logic and the connections are very simple. And just see, this is the input model. This is output model I have explained. And again, I need to connect one more switch over here, S1. Here I will connect lamp L2 and just I need to change the coding. And I can control S1 to L2, S2 to L1 or vice versa. I need to change the coding, that's it. Connection will remain same, connection will not change, only I need to change the coding. That is the advantage of PLC. The same thing, the PLC logic is not a mechanical part of control. The PLC logic is software programming which run on the processor in the PLC. This program has to be created with a special programming tool, which is ladder coding. I will explain afterward, next part of this today's presentation session. First, I will cover a little bit theory by which you understand what is a PLC. After downloading the PLC into the program into PLC, that if you want to upload the program inside the PLC, it's called as downloading in this term. The controller automatically start the program. Okay, if we provide the power, then this is all about the what is the PLC logic. Now here on the screen you can see the two diagrams. Okay, the ultimately we can see the function is same, the similar kind of input output devices are there, everything, but the diagrams are changed. Why diagrams are changed? The connections are changed because here the at the first is a physical wiring relay based circuit, what I explained previously, relay logic, and here ladder logic is there. And you can say it's little bit similar, only the symbols are different. Okay, because here we are using the physical switches. These are the push button, normally open push button, normally close push button. This is a timer relay. Okay, here some count outputs are there, PC and timer. But same thing if I want to develop with the help of ladder coding, which is virtual wiring, I explained previously that we need to upload inside the PLC. Then here normally open contact switch, normally open contact connection, normally close. Some output coils are there, some timers are just see timer here are different and here timers are different. Okay, because this is ladder coding. Okay, and based on this ladder coding, the same whatever the relay logic is there, similar kind of operation we are getting. Okay, there's a physical and there's a virtual wiring, but I need to design the ladder coding properly as per the understanding. In the physically I can see okay what things are there where I am connecting, but in ladder coding everything is logic. I need to create the logic first, develop the ladder coding, upload it, and then we need to test it whether it's working as per or not. Because in physical wiring at least I'm getting some output. Okay, ye chal raha hai, nahi chal raha hai, ye glow ho raha hai, nahi ho raha hai. But here I need to design virtually first, and then we need to go to executing. It's little bit tough. That is a disadvantage of PLC. Skillful workers are required. That is not case any the person who understand electronic part he can do. He's required logical also, reasoning also. Who does who able to create the logical execution? That person only able to design the ladder coding. Then these are the two diagrams I explained. This is a physical wiring RLC, and this is ladder programming for PLC. Now in this side we can see the machine automation overview, like input output devices which we can connect. Then here at the top you can see these are the input devices. Suppose I want to command signal, if I want to send, then I can use some kind of push button, selector switch. If suppose I want to change the status signal, then I can use the limiting switch, electrical limiting, proximity switch, read switch, etc. Many switches are there. Few are listed over here. Then these are the input switch which give the signal to the controller. Okay, might be the signal I will say HMI also, human machine interface, that it will be processed by the controller. Okay, and based on that the output signal will be generated which is goes to the output device. It might be my machine is there, whatever kind of machine is there, there's some kind of feeding mechanism is there. Okay, in that I can control the relay, solenoid, power contactors, actuators. Actuators are nothing but here I can use the motor, cylinder, heater, lamp, etc. Anything, whatever the devices are there which I want to control, I'm getting some kind of mechanical output that we can call as a actuator, pneumatic, electropneumatic, electrohydraulic. That is also possible over here. Then these are the some listed out the devices which we are going to connect with the PLC, the controller, and based on that the required output we are getting. What is the advantage of PLC? I think so most of the people they already understand whatever I explained previously. In the PLC we required very less wiring as compared to relay based circuit. The wiring between devices and relay contacts are to be done in PLC only, PLC programming only inside. It is very easier and faster to make the changes. Whatever the changes are there, only I need to change the logic. Connection will remain same. I'm not changing the connection. Whatever devices are connected will be remain same. I need to change the logic, and as per the required output we are getting, if I'm working with the same devices. If suppose I want to some more input, more output, that according to that I need to add that devices in input output mode. The troubleshooting adds make programming easier and reduce the downtime. Reliable component make this likely to be operated for years before the failure. These are the advantage of PLC. The disadvantage already I said, the troubleshooting, skillful workers are required. Okay, that is not case anybody can do and easily identify. Suppose 1,000 line of ladder coding is there, and it's very difficult to understand where the problem is there. That we need to check one by one all the rungs, the ladder coding, where the problems are there, whether we are connected the proper address, the proper input output devices or not, because that is the main the we can say the issue is there while developing the PLC setup. We need to connect properly address. Addresses are very important. That we'll see afterward. What is the address? How we can connect the input output address? How it is connected with the PLC, the ladder coding. That is a disadvantage of PLC. It is very minor, I can say, but lots of advantages are there. Now, PLC is a controller. Okay, as we saw in the video, what is a PLC? It is again one kind of control. Only thing is that the monitor is not there, keyboard is there, the mouse, but it is computer. But some kind of similarities is there. Then that we can see clearly in this slide. The PLC and the PLC and PC in comparison. PLC is also having the CPU, like CPU, RAM, flash card, power supply. It also work 220 volt and 24 volt DC also. By 224 volt DC, why it is given? Because any kind of power failure is there, then ultimately we can connect with the batteries and we can execute the required task with the PLC also, whatever the setup is there. The input here we got the keyboard, mouse, but here for the input we require the push button, selector, limiting switch. As we saw the previous slide, what are the input devices? Output, we are getting an output for the PLC like monitor, printer, projector from the PC, but for the PLC to get the output we required some kind of solenoid actuators, relay lamp, motors, HMI, and actuators. The softwares in PLC, we can use the Windows, Linux, Mac, okay? But here we are using firmware. The softwares we are using here might be one example, Office, whatever things, the softwares we are using. But here we are using the machine logic, the softwares, internal logic. The internal, we can say the work we can say here, we can do some kind of calculation, yeah, other devices, other things, addition and all those things. But here the internal, the softwares we can use the makers, timers, counter, okay, function blocks, etc. And there is a basic difference. What is a PLC and what is PC? Now in this side we can see what are the advantage over a PC, the PLC, and what are the disadvantage. The main difference from the other computer is that PLC are armed from the several condition, as I said previously, like dust, moisture, heat, cold, etc., and have facilities for the extensive input output arrangement. What are the advantage here? The cost effective. If I go and purchase a PC of 50,000 to execute a device of 10,000 is very costly. That is not possible because the same thing I can do in PC also. Nowadays, lots of that interconnections are possible. I can connect various devices to my PC, like as we are doing in Arduino and all those things, Raspberry Pi. But it is not cost effective. Why unnecessary I waste that much cost? Because PLC I can get with 3,000 to 5,000 rupees. Small kind of PLC, compact PLC I can say. If suppose I want to execute the small program, then that is the cost effective for controlling the complex system. Flexible, can we reapply to control other system quickly and easily? Suppose I want to change it. Okay, system one, whatever the system I generated right now, work is done. Let's say I developed one program in which setup in which some pneumatic control, electro-pneumatic control devices are there. If I press the button, push button, it clamps some devices, clamping and unclamping, like simple program I developed with the help of PLC. And afterward, come to know, okay, now this work is completed. I want to apply the same PLC somewhere else. That is possible. I can remove that input components, output component. I can connect somewhere else. I need to change the code, and the same PLC I can use somewhere else also. Then that is the advantage, flexible and can be reapplied to control other systems quickly and easily. Nowadays, as we saw in the video, the addition, subtraction, PID controller, lots of that the abilities are given the PLC, which was not there previously. The computational ability allow more sophisticated control. Troubleshooting adds make programming easier and reduce the downtime. Reliable components make this likely to operate for year before failure, as I said previously. That is the advantage over a PC. What are the disadvantage? Too much work required in connecting wire. Initial, okay, installation is difficult, no doubt, because we need to write the ladder coding properly. We need to identify the address properly. We need to connect the proper addresses over there as per the program. Okay, for 4-5 components, it's easy, but we are talking about the industrial process in which might be 2,000, 4,000 input output devices are there. And to connect the 2,000, 4,000 input output devices for that particular ladder coding is quite difficult. That is a disadvantage. Too much work required initially connecting the wire. Difficult with changes and replacement. Difficult in finding error, required skillful workforce, which already explained previously. Okay. What are the function of PLC? Then here I can short PLC is equal to PMC. What is PMC? Production, measurement, and control. we can measure it, anything. If I want to measure some measuring, that thing is there, I want to measure something, I can use the sensor, I can measure it, I can send the data to the PLC. Previously the PLC only we are using the digital input now, but nowadays analog input, the system is also available, PLC is also available, in which directly we can give the analog, and that analog to digital conversion is there inbuilt. Previously only we are getting the digital input output devices, but nowadays and digital and analog both are possible in a PLC. We can control, we can command and regulate, we can provide some kind of protection. Event logging, if someone want to create the logging at what process occur, or how much time when it is completed, this kind of event logging, yeah, anything, that kind of thing we can do over here. Some kind of communication, might be this part will be explained in the next session with the help of SCADA. There also some this kind of PLC we are using, and we can communicate, we can restrict the control, and we can control the completely supervisory control data acquisition system and human interface. That is also possible. And that is also the function of PLC. Now, what are the leading brand for the PLC? Which PLC we need to purchase? Then, if you go in the market, lots of company PLCs are available. Some of the names are there, reputed country, which might be you heard already. If suppose I'm talking about the American companies, then Allen Bradley is very popular. Texas Instruments, sir has explained, I think so. Texas IoT yesterday devices. Then Texas also creating the PLC also. Square D, General Electric, lots of companies are there. If I'm talking about the European company, the Siemens is very popular, Bosch, Pesto. These are the some popular companies which manufacturing the PLC. Plus Japanese companies are also there, which manufacturing the PLC like Toshiba and Mitsubishi, which are more popular to make the PLC. Then these are the leading brands. If you want, you can go and purchase. Only drawback is there, as I explained in the video. If you saw that time, only problem is that the ladder coding, the addressing style, the style of the codes, we can say the whatever the block, the signs are there, normally open, normally close, timer, counter. It's little bit change. It's not that much difficult. Everyone can understand. Only initial some time is required. Suppose if you're comfortable to make a coding with the Mitsubishi, might will create you require little bit more time to understand the Allen Bradley. Whatever the kind of softwares we are using. Previously was there only. I'm talking about the late 90s, yeah, 2000. That time, what was happened that time? Mitsubishi PLC only work on the Mitsubishi software only. We cannot use another software. Nowadays, lots of softwares are there, open source softwares are there. One open PLC we can use today also. That interconnectivity was not there. We cannot connect, I'm not getting the word, other company software, I can use another company hardware. That kind of dependency was there previously, but nowadays we can interchange and we can connect any kind of PLC with any kind of softwares, and we can download and upload the code. And these are the brands. Now, what are the application area where we can use the PLC? In manufacturing industry, machining industry, food, metals, power, mining, petrochemical. These are few are listed out, but n number of things are there. Wherever the processes are there, that process, if you want to control, if you want to create any kind of automation, then there you can use PLC. That is a possible. If you go to purchase the PLC, then based on your application, what kind of application is there? Okay, then what I'm explaining, the type of PLC. Then whenever I'm going to purchase a PLC, then based on your application, you have to decide what kind of PLC you want to select. Whether you should go with the compact micro PLC, whether you should go with the modular PLC, or whether you should go with the software PLC. Then there are the three types I can say. Suppose if you require the fixed casing, fixed number of input output pins, no process computer capability is required, then you can go with the compact PLC. Okay, in which, let's say if you decided your process is there, only 4 inputs are there, 2 outputs are, then it is fixed. I am not going to change in future. Might be after 2-3 years, 1 year, it is remain same. At the end, that process, a small project is there, I can say. Then best way we can go with the micro PLC. Some are the types, product type is mentioned in the Mitsubishi, the serial numbers was there. Okay, they are the fixed input output numbers. We cannot change it, we cannot add it, add on, it's not possible. But suppose right now you develop one process, one application, and in future you are planning to add some more inputs, some more outputs. That time you can go with the modular PLC. In the modular PLC, some racks are there. In that racks, DIN rails, DIN rails are there. 3-unit racks, 6-unit racks are there. Then based on that application, we can change the input output as per my requirement. That is not, it is fixed. Then model PLC nowadays industry is very popular. We can use it. Small MMC function is also possible. Okay. And soft PLC is software based PLC. We can say Windows, yes, C based automation product directly used with CPU or co-processor. No actual PLC is required. Software PLC, software based. Just we need to connect our devices to the system, and there we can execute as per our requirement. Now, there are the three types based on the application we need to select. Then, if it is visible in your picture, you can see this is an example of compact PLC. In the compact PLC at the top, these are the screws are there where we can connect the digital input devices. Okay. At the bottom, we can see here digital output devices are there. Here, digital. You can see here the 0, 0, 0, 1, 0, 2. I hope it is visible till 0, 15. That means 16, 0 to 15. 16 digital output pins are there. And if you can see here, again 16, 0 to 15 digital input pins are there. And here around 8, as I said, nowadays we are getting analog also, analog input output. Total 0 to 8, 0, 7, sorry, total 8 number of pins, analog input output pins also. Okay. And there's a network, we can say some kind of PGA cable, PGA port is there. We can connect and upload our program inside the PLC. That kind of connections are there. This is a simple structure. You can say one example of PLC for a type of compact PLC, micro PLC, in which the inputs are fixed, outputs are fixed. If suppose I want to change in future, which is not possible, only I need to deal with maximum 16 digital pins, 16 digital output pins, and maximum 8 analog input output. Next example, modular PLC. Again, modular PLC is classified in three types. Small model PLC. It covers up to 128 input output pins. Just see, in compact, we are talking about the 16. Just we see the example. Okay. But in modular, we are getting 128 input output pins. That huge number of devices I can connect with the single PLC, small model PLC, and which provide the memory up to 2 kilobytes. Okay. These PLC are capable for providing simple to advanced level of machine control. Second, it is medium size modular PLC, in which I can get the capability of I can connect 2048 input output pins. Again, that is a huge number, because for the plant that kind of numbers are required. So small project is not that much required, and the memory up to 32 kilobytes. Thus, we can ladder coding I can upload inside the PLC, and can control a part of process or complete process also possible. Okay. And third, large, in which 8192 input output pins are there. Just see how much huge. And if I do the coding, ladder coding of 2000, 4000 code, and I'm having the 8192 input output, just see how much complicated are there. This entire system with a single PLC. Because of that, initially I said the disadvantage is that skillful workers are required. Then also I can identify that we need to connect the proper address, proper devices, the ladder coding. Then only I'm getting the required process as per my requirement. And here the memory I'm getting up to 750 kilobytes. That much a huge size of program. The ladder coding, you can no doubt it look like very small, but ladder coding is sufficient. It's not that much small amount of memory. Can control individual production process or entire plant. So sometime in industry is required. With a single PLC, I need to control entire plant. Then we can go with the large size. If suppose various processes are there, I won't control one process with a single PLC. I can go with the medium, and I want to create the automation of one machine only, single. Then I can go with the small. And these are the example of modular classification of modular type of PLC. Then you can see here the modular. Just see, we can add it in the rail. This is a DIN rail 24-volt supply, and I can connect the model as per my requirement. I can extend and I can increase and reduce the input output pins as per my requirement. That is possible. Because of that, it's called as a modular type of PLC. And this is the last example, medium and large size. Okay. Medium and large size, these are the some racks are there in which this input you can see this all are whatever the exam. These are the input output. This is the input output. This is the input output. Two CPUs are there, CPU 1, CPU 2. Okay. Some serial connections are there to upload to do the communication. Then this 8000, whatever I saw there, large size 8192, if I'm not wrong the number. That much number of input output pins are available in a single, like we can see this is a one cupboard size PLCs, they're huge size, but ultimately whatever the sensors and actuators are there within my the plant and processes, everything I can connect the single PLC, and from the single system I can control everything over there. That kind of capability I'm getting with the help of this medium and large size of modular PLC. And software PLC, PC work as a engineering workstation. Here we can use as a human interface, visual based type of PC as a real time processor, the soft PLC, assisted by the co-processor, and field buses, gateway, and distributed input output. Then here system is there in which we are getting some visual inputs, how the process works on. Then it's more towards the SCADA, I can say, that you can learn in detail in the next part of this session, the how the soft PLC or PC as a PLC works. These are the major components of PLC. Now here PLC is the CPU, arithmetic logic, ALU, memories are there, which is connected with the power supply and programming devices. Okay, programming devices are nothing but the software, which I can say my system, which I need to connect to the PLC. I need to do the ladder coding out laptop or desktop, and I need to upload inside the processor. Some input modules are there like push button, contact, limited switch, which already discussed. The sensors are there, and some output devices are there like solenoid, contactor, alarm, etc. to get the output model. Then it's generalized, I can say. If I divided the major component, then these are the 5 major components are there for the PLC: power supply, processor, program device, input and output modules. How to select the PLC? What are the criteria to select the PLC? Then when you are going for the selection the PLC, already we see the classification. We understand what is a PLC. Now how to decide? Then first we need to decide how much number of input output pins are required. The connections are there, which I am going to connect the PLC. If I aware, okay, I'm happy. I need to connect only 4 input pins, 2 output pins. Okay, the small PLC, my work is done. But let's say if I want to connect with 50, 60 input output devices, some sensors are there, etc. And then I need to go with the modular with small size. If it is in thousands, then I go with the modular medium size. If it is more than that, 5,000, then no doubt I need to go with the large size of PLC. Next, the memory. As we saw, the memory of all the PLCs are different. Some are providing 2 kilobytes, some are providing 64 kilobytes, some are providing 320 kilobytes. Then we need to decide how much length of my ladder coding I'm doing, how much memories are required to store it. Then based on that, we need to select the PLC. Number of special input output models, whether I required some kind of analog pins or some other kind of special input output that modules. Then that based on that also we need to select the PLC. How much scan time is there? Scan time is nothing but after uploading, how much response time is there, I can say. It will provide to my system. That is not case. Here the sensor generated the signal, and after 5-second delay, my actuator react. Then ultimately my system will not work properly as per required. Then scan time should be minimum. Then I need to check the scan time also, how much scan time provided by the PLC, what kind of communication is providing the PLC, whether nowadays Wi-Fi PLC is also available, wireless PLC I can say. No wiring are required, only through Wi-Fi router I need to connect it. I can send the signal through wireless. Some are wired are there, some are internet connected PLC is also there nowadays. Then communication also we need to decide what kind of communication channel I need to going to use and what kind of softwares I'm going to use to upload the PLC. And these are the criteria I need to consider while selecting the PLC. Okay, last half an hour, yeah, 45 minutes I'm talking. Any person, if any doubt, you can raise the hand because we are going to about to finish the theory wala part. After that, we'll just cover the little bit ladder coding and we'll go one project at then bottle filling mechanism. Then you will get the idea what process we are covering to develop the PLC system. Any doubt, anyone till here? Okay. If no, if you're not any doubt, then we'll move further. Okay, this is just a schematic diagram. What are the devices? How we are going to connect with the PLC? And I can connect the input button, push buttons. If I want to control the motors, I need the contactors. I can connect the motors through the contactor with the PLC. Some kind of indicator lamps are there, whether motor is on and off. Okay, these are the devices which we are going to connect the PLC. Okay, but as I said previously, when you are connecting the devices to the PLC, I need to look the addresses also. That is a very important part because in the ladder coding, I need to specify what logic, what addresses are there because mostly we are using only, we can say the 3 symbols mostly. These are pass the normally open, normally close contact and output coil. This kind of, I can say the logic we are using mostly, but I need to differentiate. Okay, this logic is for this input button. this logic for this push button, and this logic for the motor. Let's say n number of motors are there, no, two, three motors are there. Then ultimately I'm using the same symbol again and again. But how I can differentiate which motor is where is connected, that I can differentiate with the help of these addresses. Then how we can give the addresses, that we'll see next slide. We can see these are the input output addressing. Then first I will explain how the input address I'm defining. Ultimately, as I said, logic is same, normally open contact, but address I can provide here. Like this is the example of Bosch PLC. The addressing also company to company varies, but ultimately similar. If you understand this one, then other also you can easily identify how they are giving. Only the notation are different. Some are providing the X, some are providing I, some are providing Q, some are providing the P. The letters are different, but ultimate number is same. Then here the percent I stand for input. This is a multiplication sign, not X. Okay, I multiply 0.0. Then first 0 stand for module slot number in rack. Okay, in which rack it is connected. Byte number sometimes is called as an input table. Okay, and second module terminal number, a bit number in the input table. Then let's say I'm using the compact PLC and I'm using the 3 compact PLC. This compact PLC 1, compact PLC. All PLCs are identical. Compact PLC 2 and compact PLC 3. And each PLC having, let's say, for example, 4 input pins: 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Let's say I connected one push button over here. Then I can give the number 0.2.0, sorry, 2.0, that model number 2, pin number 0. Let's say I connected one switch over here, the second, then I can give the address 3.2. Okay, like this I can give that. That is the same address 0.0. Then ultimately the initial part is same, percent ix 2.0, percent ix 3.2. Like this. By this is the addresses by which the PLC will understand whatever the input I will receive from which terminal. Whether I'm going to receive from this terminal, this terminal, this terminal, where exactly. Then that I will identify from the addresses. And that is very important part as far as ladder coding is concerned. Okay. Then this is all about the input addressing. Okay. Similarly, output addressing is also there. For output address, only difference is that the rest of the things are same. Module slot number in rack slash byte number in output table. Module terminal number, which terminal I contain that particular model, slash bit number in output table. Only difference is that instead of I need to use Q. Q stand for the output and I stand for the input. Then this is all about the theory of PLC till here, I think so. I covered what is the background of PLC. If any person having a doubt regarding the PLC theory, then you can ask me till here. Then we'll go with the ladder coding, because ultimately we understand the theory. Now how to do the ladder coding, that will see again the basic, because we cannot go with this entire 1.5 session, entire the codings, whatever the logics are there. But whatever the basic logics are there, 70-80% of time which we are using, that part I will explain over here. Then any doubt, anyone till here? Okay, great. No doubt means everyone is getting properly. Let's move further, PLC programming part. Now, what is the basic function of typical PLC? Read all the input devices via input interface, execute the user program stored in application memory, then based on whatever control scheme has been programmed by the user, turn the output device on and off or perform whatever control is necessary for process application. Okay. Then here there might be process sequencing, reading the input, execute the program memory, and updating the output, known as a scanning. Then these are the basic function of PLC which we already learned. Now to do the coding for a PLC, total 5 ways are there. Okay, we can go with the coding FBD, function block diagram. We can do the SFC, sequential flow chart. We can do the ladder coding. If you want to go with textual language, I can go with IL, instruction list. I can go ST, structure text. All these 5 are possible, but more popular are there in the industry is ladder coding. And that we are going to focus in next session. What is the ladder coding? Then to execute, to design a PLC, normally we need to go with these 5 steps. We need to define the processes proper. What process I'm going to program the PLC? How many input output devices are there for in that process? What is the sequence of operation? How the operation will be flow after understanding the process? Once we define the process, what will the sequence are there? What are the possibilities are there? Through block diagram I need to create. Then we need to program the PLC, and at the end we need to test it. whether that program is executing our logic or not, that block diagram is satisfying or not, yeah, our defined process satisfying or not, that we need to test it. That is a step we need to follow for designing the PLC logic program, yeah, system, whatever the processes are there. To do the ladder coding, as I said, 80% of time we are using only these three logic. Okay, the name of this first logic, examine on instruction. Yeah, normally on also is called, yeah, pass logic also is called, and whatever you can use. And this is the examine of instruction. What is examine on? Examine on stand for if the whatever the device is connected to this logic through the address, whatever the address I set. For example, let's take the example of this PLC, and this is input 0, 1, 2. Only 4 inputs are there, and let's say 2 outputs are there. Let's assume. Okay, very small size of PLC, which is not there actually. I'm just assuming. And here I connected one push button, and here I connected the push button 2. This is S1, this is S2. Let's say S1 through address I connected over here. I write the percent IX as I used previously 0.0, and here I provide the address percent I in the logic logic X 0.3, 0.3, model number 0, pin terminal number 0, model number 0, terminal number 3. If suppose this is open right now, this is open, this is also open, the state of this two S1 and S1 is open, that means the logic is 0. Here also logic is 0. Logic is 0, no doubt. If it is open is 0, if it is closed 1, as per the digital logic is concerned, 0 and 1. Then if it is 0, and if I connect this switch to this logic examine on, then it will pass same logic. If it is true, it will pass true. If it is false, it pass false. Then it will pass same language 0, right? Because right now is 0. If it is 1, it pass 1. The same thing is written true if address bit is 1. मतलब ये true कब होगा? जब address bit जो input provide करेगा, whatever that I'm providing with S1, it will 1. And whatever this examine off, this examine off, it is 0, then it will pass opposite examine off. If it is 0, it will pass 1. If it is 1, it will pass 0. Opposite, totally opposite react. True if the address bit is 0. तो यहाँ पे opposite. यहाँ पे true कब होगा? जब bit 1 होगा. यहाँ पे true कब होगा? जब 0 होगा. Because of that is called as examine on, and this is examine off. तो true होने पे ये 1 होगा, ये true होने पे off होगा. This is all about the logic of S1 and S2. I can connect with input also, I can connect output also. ऐसा नहीं input भी connect करते हैं, but there is a logic that is important. It pass the same logic, it pass the opposite logic. जो state रहेगा, जो अभी right now I connected this logic with switch 2, तो switch 2 का जो state होगा उसको opposite pass करेगा. If switch 2 is 0, it will pass 1. It will is 1, it will pass 0. And this is examine on. It will pass same state. If S1 is 0, it will pass 1. If S1 is 1, it will pass 1. Sorry. If S1 is 0, it will pass 0. If S1 is 1, it will pass 1. That is the basic difference, examine on off. And this symbol, last wala symbol, okay, ये दो symbol देखा हमने, examine on, examine off. This is called as a coil, output coil. Okay, and this is normally we are connected for the output devices. Because of that, here the address is written %QX 0.0. Okay, then here true if the previous rung examine on with the same address, examine off with the same. What does it mean that? Normally in ladder coding, अगर if I draw the ladder coding ऐसे दो हमें रंग draw करना होगा, और यहाँ पे हमें कुछ logic pass the ये examine on, examine off, whatever, n number of examine on, n number of examine off, I can add it. Here I just added single examine on and single examine off. And at the end, this rung should be add at the coil. जो रंग मुझे end करना है ना यहाँ पे end में, coil से end करना है, because हर रंग का एक output रहेगा. This रंग एक output होना चाहिए coil, and that should be on right hand side. मैं लेफ्ट में कभी रंग नहीं बना सकता. सपोज इफ आई मेकिंग रंग ऐसा लाइक दिस कॉइल विल पास द लॉजी, इनवर्स द लॉजी, जो अभी यूज किया examine on, examine, तो ये रॉन्ग है. दिस इज रॉन्ग टोटली. Always each rung ended with the output coil. Okay, then this output coil will give the output only depends if all the state of this is 1 1. If this is also 1, this is like n number of 5 are there. If all 5 1, then only it will give the output as a 1. Otherwise it will give the output as a 0 if anyone is 0. Like AND logic, if you remember AND logic, if all are true, then only outcome will be true. If anyone is false, the 0 output will be false. That kind of operation I am getting if I'm creating the rung like this. If suppose I'm creating the rung, pass the logic, output coil, and here also one more pass the logic, I'm doing the branching over here. That means single output I'm connecting with the 2 examine on, but both are connected with parallel. Then here I'm getting the OR operation, OR logic. Here this is the AND logic, and this is OR logic. OR logic means one, if any one is true, output will one true. समझो ये 0 है, ये भी 0 है, then output I am getting 0 only. But any one from this is 1. Let's say this is 1 and this is 0, then output will be 1. Or this is 0, this one is 1, then also output will be 1. If both are 1, then also output will be 1. If both are 0, then only will I am getting the output is 0. Like this also I can create the rung. Then this is AND logic rung and this is OR logic rung. Then this kind of logic I can create with the help of this 3 symbol. Because of that, say 80% of time we are using this 3 symbol only in ladder coding. If you understand this properly, what is examine on, what is examine off, what is we can say this coil, how it works, then you can easily understand what kind of logic I'm getting in that ladder. Okay, there's a 3 the code instruction which mostly I'm using: examine on, examine off, and coil. There's a small program, latching wala program. Latching wala program means what? Let's say agar maine let's say suppose I created a ladder rung a start, stop और coil मतलब सब लेट्स से यहाँ पे हमें मोटर कनेक्ट किया, मैंने मोटर कनेक्ट किया, तो ये रंग को मैंने सिंप्लीफाई किया विदाउट लैचिंग आई एम नॉट यूजिंग द लैचिंग. देन व्हाट विल हैपन, लेट्स से यहाँ पे मैंने पुश बटन यूज किया है, ये मेरा पीएलसी है, दिस इज आवर पीएलसी, ये स्टार्ट के लिए स्टार्ट, और एक मैंने पुश बटन यहाँ पे यूज किया है, वी यूज फॉर स्टॉप लेट्स एसपी एंड स्टार्ट, एंड हियर आई एम यूजिंग द लैंप, आई वांट टू लैंप या मोटर व्हाटएवर, लेट्स से मोटर कनेक्ट किया मैंने. Then this is push button. This is a push button. I press, it will pass the current, it will pass the signal. If I release, it will again come to this original state. Then what will happen? For stop, I'm using the inverse logic, examine on. For start, I'm using the examine on, and for stop, I'm using the examine off. Sorry. Then both the state right now 0 0. ये 0 है, तो ये क्या pass करेगा? If this is 0, it will pass 0. Same logic. And this is examine off. ये 0 है, तो ये 1 pass करेगा right now. So as is the AND operation, if it is 0, this is 1, outcome मेरा 0 ही रहेगा. It will not change. Okay, right now. But let's say if I press the push button, start button, if I press, it will connect. The state will become 1. If this is become 1, this will become 1. I am not press stop button मैंने press नहीं किया, खाली start button press किया है. It will 1. Both are 1. Then I am getting output as a 1. Output as a 1. Motor will be on. मैंने start button press किया, motor on हो गया. But if I release the start button, start button, what will happen? If I release the start button, again it will come to this original state 0. It will become 0 and motor again stop 0. That means stop switch is no use right now. Stop का use मेरे को start से ही है. Only single use I'm oning and single use I'm offing. Even though I use the ladder coding, ladder में भी use किया मैंने, logic connect भी किया physically, but it's not working. Why it's not working? Because I have not used the latching. Then to execute as per our requirement, if I press the start button, motor should on, and even though I release the start button, motor should remain on, I need to use the latching. Okay, then what is latching? Physical wiring remains same, physical wiring में change नहीं होगा, only I will change the coding coding I will use, coding I will change, and in the coding what I will do, instead of the previous वाला जो simple code किया था हमने, उसकी जगह we are using this one latching. यहाँ पे latching में क्या किया हमने, here I can write motor also. यहाँ पे motor लिख के मैं यहाँ पे motor लिख सकता हूँ. Okay, यहाँ पे motor लिख सकता, that is possible, no doubt. ऐसा single रंग भी बना सकता हूँ मैं, CR यूज करके यहाँ पे मैंने motor लिखा है, तो ये रंग I can cancel it also, but there are the two ways, direct control and indirect control. Then here we are using the indirect control for the safety purpose. Because of that, here I am using the control relay. Okay, and through relay I am controlling, internal relay. Through relay I am controlling. Ultimately output is same. मैं relay को signal दूंगा, relay motor on करेगा, same. Then here what is the state? 0. ये 0 पास करेगा. What is state? 0. ये 1 पास करेगा, और आउटपुट तो ऑन ही नहीं है, तो ये 0 रहेगा. बिकॉज मोटर इज ऑफ, तो रिले भी ऑफ रहेगा, तो रिले ऑफ है तो ये भी ऑफ रहेगा, मोटर भी ऑफ रहेगा. दैट इज द इनिशियल स्टेट व्हेन आई एम नॉट टचिंग एनी स्विच. लेट्स से आई टच दिस स्विच राइट नाउ. अब मैंने इसको टच किया, मैंने प्रेस किया, दिस इज बिकम 1. ये 1 हो गया, ये 1 हो गया, तो स्टार्ट का स्टेट 1 हो गया. ओके, बोथ आर 1, स्टार्ट 1, स्टॉप 1. इफ बोथ आर 1, कंट्रोल रिले विल बी ऑन. When the control relay will be on, immediately that time this examine on, this 2 will become 1, because it will take the state of this coil. This is not physical switch, ये physical switch नहीं है कोई, ये खाली यहाँ पे जो स्टेट रहेगा आउटपुट का वही स्टेट लेगा. अभी आउटपुट ऑफ था इसलिए ये ऑफ था, आउटपुट 1 हो गया तो ये भी 1 हो गया, ये भी यहाँ पे 1 हो जाएगा, यहाँ पे 1 हो जाएगा. इफ why I press the start button, because of that CR1, ये भी 1 हो जाएगा, तो ये 1 हो गया तो मोटर भी ऑन हो जाएगा. As we did previously, same thing right now also the same thing will happen. But when I release the stop button, when I release the stop button, it becomes 0. It becomes 0. Then here also it becomes 0. Okay, but motor will not off. Why not off? Because CR बनता तो यहाँ पे 1 हो गया, ये इसी का स्टेट लेगा. Then this is the OR logic. ये कौन सा लॉजिक है? OR logic. यहाँ पे है ना, पैरेलल है, OR logic. If this is 0, this is 1. The resultant of this branch will remain 1. Resultant of this branch will, because these are two parallelly connected, 0 and 1. That it is 1. If both are 1, output will remain 1 only. It will not off, because even though I'm releasing the start button. Then this is the latching, and most of the time we are using this latching wala command in our system as per our requirement. Okay, and if I want to stop it, motor will remain on even though I'm releasing the start button. If I want to stop it, I need to press the stop button. When I press the stop button, it become 1. ये 1 होगा तो ये पास 0 करेगा. Okay, no doubt इसका resultant 1 है, but 1 0 ये AND operation. अब ये resultant क्या है? ये series में. This will be the AND operation. This is OR. This is AND. The resultant of OR is 1, and the resultant of OR and this stop button is AND. Is 1 and 0, तो ये 0 हो जाएगा. ये 0 होगा तो ये दोनों 0 हो जाएंगे. अब 0 0 और motor off हो जाएगा. Then that is the benefit of latching. And whenever I'm using the push button and I want to control the any device, motor, lamp, anything with the push button, then I need to use the latching. Then this is called as a latching. इसको latching बोलते हैं. इस part को is called as a latching. We use the latching. Any doubt till here? Anyone? Now we'll go directly jump the timer. Timer on delay, timer off delay, and pulse timer. Okay. Timer on delay we use when after giving the input certain amount of time the system should be on. Okay. Timer on delay, it will take time to on. Timer off delay, it will take time to off. Okay, after certain amount of time it will off. And pulse timer, it will not wait for on off one. If for a particular pulse, it will work. How much time is required? To get it proper understanding, I will use the Open PLC software. Okay, this is a one program Open PLC. I will explain after how to download this. Okay, where we can do the ladder coding and do the simulation. Okay, then here I created the 3 rung: timer on delay, timer off delay, and pulse timer. And if you execute, then we'll get the idea how it works. Yes, here I'm getting the status. Once it is done, it will show over your console. Just see the PLC started. Now I'll go the instant debug start and we'll check. For timer 1, we can provide the sensors. The sensors, any kind of input, and this is output. Let's say 3 motors are there: motor 1, motor 2, motor 3. Okay. Only problem is that I forget to provide. Previously it was not showing because of error. Now here I'm giving the everyone 5000 millisecond, 5000 millisecond. मतलब 5 second का मैंने timer दिया. But functions are different. This is a T1 timer on delay, timer off delay, and pulse timer. For timer on delay, suppose if I press the push button, and after certain delay, it will react. Let's say 3 motors are there: motor 1, motor 2, motor 3. If I press the push button, motor will not start here. Just see, it is still black. After 5 seconds, 2, 3, 4, 5 seconds के बाद motor on होगा. Okay. That means after providing input, if suppose if you require certain delay for the output, then I'm using the timer on delay. If I release the input, motor will be stop immediately. Okay. But when I start, after certain delay, motor will be on. Timer on delay. Okay. Again, I'll stop it. Timer off delay. When I provide the input, immediately motor will be on, because it is delay off, not on. Immediately will be on. But after releasing it, input button, it will take delay time to off it. Because of that, it's called timer off delay. Clear? And in the pulse timer, when I start, it will on it immediately. Okay. And even though it is on, after 5 seconds, it will be off. It will work for 5 seconds only, not more than that. Okay. Then might be thought that it is look like a timer off delay only. Sir, yeah, on ho gaya, 5 seconds बाद off ho gaya. It's similar. But timer off delay, what will happen when I screw it? Timer on ho gaya, 0 on ho gaya. When I release it, then only it will off. Immediately off नहीं होगा. When after releasing only it will work. But even though if it is on, it will not off यहाँ पे. Because it will work on the pulse only. It will not depend on the input. Once it receive input, timer will be on immediately. Then this is a pulse timer. These are the 3 timer: timer on delay, timer off delay, and pulse timer. Next, I will explain after timer. This example as shown here, this ladder diagram, Open PLC. Suppose I'm using pulse counting, frequency reading, pulse generation, time management, event counting. That time you can use the counter and timer. Then instead of using this, the simple program, I will go with the one application directly last. Hardly 15 minutes are left. Okay. One application we'll see directly last, and then we'll wind up this session. How to develop the PLC ladder coding for any process, bottle filling process. Then this is the bottle filling process in which we need to fill what are the bottles which are moving on this conveyor belt, okay, which is connected with the motor, okay, and we need to open this valve, which is solenoid control valve, for 7 seconds, and after 7 seconds the bottle will fill and it will go, and based on that we are using some sensors to count it, how much bottles are passed. Then this is a process for bottle filling mechanism that we need to control. Then, as we saw the previous slide, whenever we need to create any kind of PLC program, we need to define the process first, define how much input pins are there, how much output pins are there. We need to develop the block diagram. Then we need to develop the PLC program, and after that, at the end, we need to test it. Then let's define the program. Then, as I said, in the tank, the liquid is there, and that liquid we need to fill in the bottle. Okay. Then here, some control push buttons are provided on the panel to control this divide. This 3-button knob are there to make it this process manual, auto, or off. This is off mode. Okay. Some input pins are there. Okay. The 4 sensors are there, we can say, to present the sensor. This sensor 1 will detect empty bottle. This sensor 2 will detect whether the bottle is reached exactly below this wall. And this sensor 3 will detect whether how much filled bottle is passed. Then 1 and 3 are counting. This 1 and 3 are for counting. 2 is to detect the bottle is reached exactly the below wall. Motor is there to control the conveyor belt to move it forward and backward direction. The solenoid control flow control valve is there to control the flow. Okay. And some LED light is there to identify the whether system is running in manual mode or auto mode. Then here we define how much input output pins are there. Then we can see here, then 1, 2, 3, 4, 5, 6 push buttons are there. This is again one kind of input to make it manual, auto, or off mode. 3 input sensors are there. Okay, these are all the input. Outputs are nothing. We can get the output for a solenoid valve that I need to control, motor, forward and reverse, and this lamp. This is also one kind of output. Then output, I can say 1, 2, 3, 4 outputs are there, and this 3 and this 6, 9. And if I consider these 3 inputs, then total 12 inputs are there. Okay. Then these are the input. Then I identify how much input output pins are there. What is the process? The process is nothing but when it is in off mode, zero mode, sorry, O mode, then system will be off. It will not work in all. Everything will be stopped. When it is manual mode, the system will run in a manual mode. Manually, I need to control everything. No automation will be, no automatically will control. But when in auto mode, then it will be controlled automatically. Everything will occur as per the requirement, the cycle. Then let's say the system will be manual mode, sorry, auto mode. Yeah, sorry, manual mode. When the system will be manual mode, then I need to control entire thing with this 3 button. When I press this button, the motor will be move forward direction. When I press this button, motor will move reverse direction. After releasing, motor will be stopped. Until I'm not pressing, then I'm getting forward and reverse direction. And when I'm pressing this button, then valve will be open. Then I need to press forward button, bottle will be move forward direction. It will come over here at this location. Manually, I need to see, I need to stop it, I need to adjust forward and reverse, and at then I need to open this valve. This photo sensor, we can say, it will not work in manual mode. In manual mode, I need to control only forward, backward, and valve control. Only these 3 switches I need to control entire process. But if I go in auto mode, what will happen in auto mode? Motor, I need to press start button to start the process. Okay, motor start moving in forward direction. When the bottle is reached exactly in front of sensor number 2, the motor will stop and valve will be open, and the entire process will be occurring in 7 seconds is required to fill the bottle. For 7-second delay, after 7 seconds, motor will stop and valve will be closed. For 7 seconds, valve will be open, because to fill the bottle, 7 seconds are required. And again, motor will start moving forward direction. When I press the stop, the entire process will be stopped. Motor will be stopped. The sensor 1 I use to count how many empty bottle enter in this conveyor belt. Sensor 3 to count how many filled bottle pass from this conveyor belt. Reset button is there to reset 1 and 3 count, whatever the count is stored in 1 and 3, that we are using for the reset. And this light here, as I said, we will use if it is whether it is in manual mode or auto mode, the light will be glow. In the manual mode, manual light will be glow. In auto mode, auto LED will be glow. Your lamp will be glow. Then this is the entire process, input output that we identify. Then here I can say the first 2 steps we are completed for this process. We define the process, we identify how much the input output pins are required, and we understand process also. Based on that, we need to create the block diagram. Okay, then this is a block diagram, whatever I explained right now. Then here we can see the conveyor off mode is there. Right now it is off mode. If I go with the auto mode, what will happen? The conveyor auto mode will be on. I need to press the start button. Motor start moving forward direction. When sensor 2 will be detect, it will stop the motor for 7 seconds. Valve will be open. And again, the same process will be continue. Same thing. Second bottle will come, it will block. It will stop the motor. Again, 7 seconds later, valve will be closed, and same cycle will until unless I press the stop button. When I press the stop button, motor will be stopped, and again I will need to check the mode, which mode I need to go. It is off mode if I press the stop button. But if I go in manual mode, it conveyor will be go in a manual mode, and with the help of 3 button, 3 process I will get. If I press reverse, motor go in reverse mode. If I press forward button, motor will go in forward mode, and if I press that wall, then for momentary wall will be open. The bottle will start filling. When I come to know that bottle is exactly below wall number 2, the bottle will be open. This is a block diagram. Okay. Now we define the process, we define the input output, we understand what is the sequence. Now we need to do the program. For programming, already for this state, I completed the program. This I will show the program. It is very difficult to create the program over here right now within half an hour or 10 minutes. Then already I created, then we can just see the program directly. Bottle filling process. This is a program for the entire process. I know it is very difficult, but again, the process is also very complicated. Then program is very simple. When I press the start button, start off. If you remember, the same latching is there. Normally start off, we are using the latching. When I press the start button and auto mode is on, the auto run will be on. Okay, auto run on hoga, latching hoga usme. Even the stop button release, auto run on ही होगा. When I detect the sensor 1 bottle, might be manual or auto mode, koi bhi mode mein, it will count the data. CTV is used for the count. Okay, when the sensor 3 will detect any bottle in manual or auto mode, anything, it will count the filled water. Then this 3 run to use the how much bottles are filled. It is you count the empty bottle. This is for the counting the filled bottle. Sensor 2 is used to start the timer. Here I'm using the counter. Here I'm using timer. Only sensor will work on auto run, auto mode, not in manual mode. Just see, I use the auto run. Then when sensor 2 detect the bottle, timer will be on for 7-second delay. I said 7-second delay will be there. In auto mode, sensor 2 detect the bottle and discharge is not on. Till that time, valve will be open. It will fill the bottle, and after 7 seconds, discharge will be on, and it will close the valve. It will be close the valve. Here in auto mode, the motor will be stop. Sorry, motor forward will stop when the sensor to detect the object. Otherwise, motor will be continuously moving in forward direction, or discharge is open. अगर discharge open है तभी stop रहेगा. अगर detect है तभी stop रहेगा. Otherwise, वो move forward करेगा. In manual mode, this is OR operation. और auto में ऐसा होगा तो manual में कैसा होगा? I need to press the forward button. Then only motor move in forward direction. Reverse direction auto mode में है नहीं. In reverse direction only we are doing in manual mode. I need to go in reverse direction. When in manual mode, light will be on. Auto mode, auto light will be on. Then entire process I cover in the ladder coding. Then our this part is also completed. Sorry, PLC programming. Now we'll move to the last part for testing the PLC. For the testing the PLC, we will go in a run mode. We'll test the coding, whatever the coding we created, whether we are getting required process or not, whether the code is right or wrong, and we'll just go in run mode. Okay. In the console, it will take some time to. Okay, I'm getting some error. As it is open source, it required some time. Even the code is right, it throws some error. And just close it and open it one more time. It will run next time properly. Just like PLC started. As I said previously, it throw the error, but now it is executed because we close and open it one more time. Now we go in execution mode and just see. I will just give some space by which everyone can visible. This is the code. Right now, nothing is happening. Light is off. Manual is auto is light off. Manual off. Motor is not moving reverse direction. Motor is not moving forward direction. Walls also closed. This is a dummy relay which is not used. Okay, nothing is working. Why? Because system is off. To start the process, I need to decide whether I need to go in manual mode or auto mode. Let's say I need to go in auto mode. Then I will click auto mode. Auto mode, I clicked. After pressing the auto mode, as you can see, just will go in here in first slide by which you can see. After pressing the auto mode, I need to press the start button. Okay, to start the process. Then here I will go and state the start button. When I press the start button, just see the auto run is started. Auto run is started, and after that, motor start moving in forward direction. Just see, motor is start moving in forward direction. Motor start moving forward direction. When motor start moving forward direction, first this sensor one will detect the empty bottle. Okay, then we'll go and just make it sensor one true. Right click, make it true. It will count it as a one. Okay, वहां से bottle pass होगा तो false हो जाएगा. इसने one count किया. After that, bottle will reach the sensor number 2. Okay, sensor number 2. Still motor is moving. Still motor is forward and moving, and it reaches sensor number 2. I will make it true. Okay, and timer will be on. Or for 7 seconds, the wall is open. Just see, and motor forward is stop. Motor is not moving. Wall is open, and after 7 seconds, wall is closed, and motor start moving in forward direction. And now motor is moving forward direction. And it will reach sensor number 3. When it reaches sensor number 3, again it will make it true and false. True, motor start moving. Count it 1 and make it false. Okay, just see the two counters are dead. Sensor 1, empty bottle is 1, filled bottle is 1, and still motor is moving in forward direction, and light is on. Auto mode light is on. Okay, again if you repeat the same cycle, second bottle reaches the sensor number 1, it will count it 2. Okay, sensor number 2, again make it false and true. Then timer will be on. For 7 seconds, motor will be stop, wall will be open, and after 7 seconds, wall will be closed, motor start moving forward direction, and same thing will be continuing auto mode. If you make it true and false, it counted the two button pass, 2 bottle pass VMT and 2 bottle field are passed. If I press the reset button, then whatever the counts are stored inside, it will be resetted. Just say true, false, sorry, false. All the counts are resetted 0. This is auto mode. If I go in manual mode, then what I need to do, I need to release, I need to stop it first. I will stop the entire process. Okay, I need to stop it. I need to stop the auto mode to get in manual mode. Okay, everything has stopped. Okay, everything is stopped. Now if I want to go in manual mode, I need to go manually. Then manually what will happen? Only I need to use 3 buttons. For manual mode, I need to press start for that forward and backward direction. For the manual, what I will do, I will press the start button. Sorry, for manual I will go here. Manual mode I will need to on. I will on the manual mode, and I will just select the forward direction. I will select the true forward direction. Motor start moving forward direction. When it reach exactly below the wall, I will release the forward direction. Motor will stop. I need to click the wall button. The wall will start filling. I need to check manually, and after 7 seconds, I need to stop the wall. If I want to adjust, I can click the reverse also to whether the bottle is reached exactly the below or wall or not, and just seal the light off manually is on. So like this, we can control the entire process auto mode or manual mode with the help of this ladder coding. And we tested and we executed all the tasks as per mentioned in this problem statement of bottle filling mechanism. Then here I can conclude regarding the PLC, how to design the PLC, how to execute the PLC, what are the processes we need to follow to execute the PLC, and what are the theory parts from my side. Thank you. Thank you very much. If any doubt, you can ask me.
Thank you, sir. Participants, if you have any doubt, you can put it in the chat box or you can unmute yourself and even ask the questions.
Sir, there was one question actually. So there are a lot of controllers you told us, Allen Bradley, Siemens, or other things, ABB. So if I have a same ladder diagram, so where the controller, why the controllers are different? Because what it makes its difference in the basically ladder diagram or other things? That is was the question.
Sir, as I just explained in the video, if you remember, initially I showed the video. In that, ladder diagram is remain same. The logic is remain same, not ladder diagram can say. The symbol and addressing is different, because if you use the different manufacturing PLC, the addressing style is different. The little bit we can say the coding, the block diagram. If I want to show the Rockwell automation, just I will show one PPT right now. This one I can, not this one. This one. This is for Rockwell automation. Okay. And if you check over here, just see now whatever the symbol I used, it is used for the open PLC. But symbol for the Rockwell automation, it is little bit different. Not Rockwell Automation. It is for Bosch company, whatever the InterWorks softwares are used. The symbols are little bit different. The addressing style is little bit different, but logic is remain same again. Logic is not changing. Okay, then that we need to just see the timer, in which fashion I show the timer in Open PLC. It's little bit different. The things are same. Ultimately, 4 inputs are there: IN, PT, Q, ET, but representations are different. That much changes are there. Rest of the things are similar. As I said, if you understand the logic properly, ladder coding from any style, to understand the other ladder coding and the logic, it is very easy. You quickly understand how it works. I hope you got it, sir, what I'm explaining.
Yes, sir. So whether it is can be changed from one controller to other controller, that was the question actually.
As I said, now
Whether
we can,
if we are written for Allen Bradley, then whether it is possible to same ladder
as I said,
diagram
it is
for.
possible, no, sir.
Yes,
The
sir.
only representation is different. We can create there also ladder coding, similar kind of there also, with the same logic. Anything else? Any doubt? The participants?
Sir, I had one question.
Yes, ma'am.
If in case I am having a temperature sensor, and if I have the value of temperature 30 degree, and then I want to go ahead with some conditions, so is there any block available in PLC which will catch, because temperature sensor is continuously going to sense the temperature, right? Once
Correct.
it has reached 30, is there any block which can check that, okay, yes, it is 30, and now the further process can be done? Like we have timers here, but anything wherein we can check the value of the sensors, any block in PLC like that?
Yes, ma'am. It is there, no doubt. Might be here. If we are using the temperature sensor, that means we need to use the analog input output pins, because here we are
Yes, right.
continuously getting the data, some kind of data, and that data we need to store. Then, as I said, the arithmetic operation, addition, subtraction, and division. Then there we can store the data within that bit. Data manipulation, some blocks are there. I'm not remembering the name. In that we can store that data, and based on that we can execute the task as per our requirement. Here it's whatever the symbols I explain over here: pass the logic, inverse the logic, this examine on and examine on. It's for only on off digital kind of switches,
Right.
0 and 1. But for the analog, the different blocks are there. There we need to store that data, and based on that we need to execute as per our requirement.
Okay, sir. Thank you, sir. Any further questions from anyone? Thank you, sir. It was quite an informative session wherein you have explained for PLC right from the basic concepts, its advantages, different types of PLC, how can we select a PLC, and then we went ahead to the programming of PLC. This will quite help us for different projects when we take in for students. So thank you, sir.